Alright guys, I made a mistake, and I'm going to show you how to problem solve so that you can correct your mistakes too. This is just the way I think, and this is how I solve problems. Welcome to the Dev Method. My name is Ricky. So my problem I had was I had a crash in my iOS application, and it's a crash I've never had before. As I was using this particular library, it's a library that I created myself. I had no problems with it, but as the app widely adopted more of those features, then all of a sudden I ran into a crash. Never seen the crash before. Didn't make sense to me. I looked at what I thought was correct. I had realized in hindsight I made a lot of assumptions, and so now I needed to prove that my assumptions were correct. So the issue that I had was had to do with Hashable and synthesizing the Hashable properties out of a struct at compile time with Swift. So I want to introduce you to Hashable. I've had a video on this before, but if we take a look real quick, Hashable, it's a type that became hashed into a hasher to produce an integer hash value. So imagine you have a bunch of properties on your struct. You have a name and an age and a birth date. All those things can be hashable because they themselves are hashable. So all the properties of that struct are hashable. And so therefore, there's a couple of assumptions we have to make when using hashable. So if it's a struct and all the properties are hashable, such as a string, something like an age, so an integer, and then a date, which is also hashable, then we have no need to write our own hash function, or we don't even have to write a equatable function either. So I ran into this problem where I couldn't get, I got this like strange error. So I want to show you what that error is. Give me a second to look for it. Okay, so this was the error that I got actually in my crash logs, and it was an assertion failure, and it said duplicate elements of type, and then it says the type name. So I had at least that to go off of. Were found in a set. This usually means either that the type violates hashable requirements or that the members of such set were mutated after insertion. So what does this mean? This means every time you have a set, it's a mutable set, you want to insert something new into it, a new item. It's checking this internal consistency to make sure that, first what it does is just see if it has capacity to add more to the set. So if I added two objects that are essentially supposed to be the same, like they have the same properties, so two Rickies, add them into the set, there would be one Ricky count. So even though I made two instances of it, or maybe constructed two separate values, Ricky 1 and Ricky 2, but they have the same exact property values, that would count as one in the set. So based off of this here, my thought was, well, I did everything correctly. I let Swift synthesize my properties, and that's all I needed to do, but that's actually ended up not being correct. So I just want to review here, hashable. So this here, this struct, here's the example on the website. It's a grid point that's got a y and an x. And there are vars here, but they could be lets as well, who knows. So now you add an extension to make it hashable. And this is essentially kind of like what an equality function might look like for something as simple as grid point here. So it would just be the first value, the left and the right. You just left and right meaning just the first thing and then the second thing. And this is a static function too, so this is not an instance function, so there's no like self involvement here. So it's just two things on the left-hand side and on the right-hand side of this infix operator, which is what we're overriding here, which is this equality. What we're saying is, are the two x's equal and are the two y's equal? And if that is true, then the two objects are equal. That's the idea. Then the other part to this is the hash. So there's been a little history behind hash. You might have to implement one yourself way before, I think Swift 3, 2, and 1. you had to implement your own hash if you wanted a hash. I don't even think sets were involved in the initial Swift. I don't know. If you know sets were involved in, or not involved, if sets were included in Swift 1, just let me know in the comments below. Everyone else could learn from that. But this is what it looks like modern day. Now here's the thing though, it's a struct. So what this is essentially telling you to do is you can add your own conformance to Hashable and you put your own implementation in it. But something that this isn't showing you, at least not right with this example, is that you actually don't need to do that. So what do you need to do to solve this problem? I think this is my criticism of a lot of the Swift documentation. It's just not enough. There's clearly been some thought put into it, and there's really great example. There's also like a Swift book. That's still not good enough either, because I can go to blog posts like this and I can learn so much more. So this is a blog post by Bruno Rocha. I don't know exactly how to pronounce his name, but Bruno here has a really great website, and it's all about reverse engineering, and it's really talking about like iOS and Swift. So this is something I did a lot of Google searching and eventually found this somehow. So what he's talking about here is just how Hashable works, and this is probably something that should be in the documentation. But essentially what he had talked about is like the old way was you declared a struct, and then you had this computed property, which was a hash value, and you just somehow got a hash value out of it. What he's also trying to explain here too, which I actually didn't know, was that apparently XORs, so that little like caret symbol, that is supposed to be the way that you computed your hash, which is not something that I learned. I learned like Block's hashing algorithm or his equality algorithm. And that's not something that I had ever seen. But what I do remember from my own education and background was that a hashing algorithm is actually really difficult. And if you're writing your own, you're probably going to make a mistake. It's not going to be evenly distributed enough. Because the whole idea of the hash algorithms, you want to reduce collisions. So you could have like a instance of a person that has a name, an age, and a date, and they all are different. But just because of mathematics and some of the limitations of these hash algorithms, it actually might come out to be equal with a completely different value, like really strange values. Like if it said Ricky is the name as a string, for example, there might be some other weird combination of letters that also turn out to the same hash as a string that is completely different. Like if you did equality on them, you would see that they're definitely not equal, because the equality would go through every character and just check like the character code of each one, and they would all come out to different integers, so you knew they weren't equal. But if their hash value comes out the same, then that's where like your hash algorithm has failed. So it might work most of the time, but then there's those collisions where all of a sudden it actually doesn't work. And now what is the set supposed to do when you insert something that is clearly not equal to the last object, but the hash value is the same? So what do you do? So either way, I have this here, this example to show you where this is essentially what the compiler was putting in for us. So like you just declare your grid point, right? This is kind of like the grid point and the X and the Y. And then from here, you don't do anything else. And at compilation time, this is actually what Swift was putting in for you. So I guess this is just what he's suggesting that, what it might have looked like when the compiler put this in. It also talks about some more details of mix int. I'm not going to go into that, but you can read up on that if you want. I'll put the link in the description so you can read it. Then he talks about safe hashing algorithm, but then he talks a little bit further into the future of Swift. And now we have this hasher. So it's like the hash, they got rid of hash value, computed property, and now you do hasher or do hash. And essentially you combine all your properties. So you just list all the properties that you want hashed. So this leaves a little bit of room for mistake. You might have like 20 properties, you add a 21st, and you forget to add to the hashing algorithm. And then that 20th property might actually be the difference about what's different between one object instance and the other, or the other value type versus the first value type. So then, you would have made a programming mistake. So this generated compiler hasher is doing this for you so that you don't forget that. So you can just add in that extra property later on, and then it works. Or you take out one of the properties and it still just works. So I think that's great, but I ran into an issue where I was customizing it because I wasn't using structs, I was using a class. So I'm going to show you an example of that a little bit later. But just to give a rough overview, it talks in general how the hashing algorithm actually works. I think it's really awesome. I read through it one time so far. It even tells me some things I never knew that Swift actually had, or what it was doing under the hood. And I now know that SIP hash is the hashing algorithm used with Swift, and that the hash algorithm actually has a seed that is different it's different dynamically based on each run of your program or your application. So between different Swift features, it's not necessarily going to be the same, or Swift versions, but also different executions of your program, it's not going to be the same as well. So I think that that's pretty interesting. But that is something, I guess, that is in other programming languages, like introduced in Perl 5. It's in Ruby now and in Rust. Great, cool, I didn't know that. This is actually such a good resource. I wish it was part of the Swift documentation to start. But let's get deeper into what my issue was. So I told you about this assertion failure. So then I looked at the logs. All right, so here are my logs. As you can see, this is my last line of code that I wrote in the application, and this is part of one of my frameworks here. It's the application code. And then all of a sudden after that, if you go up the stack, it's like the next step, a function called a function, which called another function. So this is all about inserting into a set. And then on inserting new, there's a check to see about resizing, because we need a copy of another set. So I found that interesting. That's another just small little tidbit. As you just make an empty set, you add something into it. Great, it's got the one item, but you add a second thing into it, it's actually resizing again. So it's constantly resizing. I thought that was interesting. And that's probably why when you have a set, if you have an idea of how many things are going to be added into it, you should put in an initial capacity to eliminate this. But either way, without changing a lot of my library framework and some of the interface there, I at least wanted to get this far, which was using it. And as you can see, it all ended up with this assertion failure and that strange issue that I had. And so it was all about resizing, and it copies and resizes. So it takes those items, moves them into the next set. So copies all the items into the set. That's kind of the idea. I don't necessarily say it's doing like an actual copy, but more just like moving them into the new set. It's maybe making a copy of references or a copy of the value types. But that's where things went wrong and had a lot of crashes. And it's literally because I just started adopting this newer feature in not even many areas, maybe like 3 different areas of the application. And it's the combination of user taps and clicks that this sometimes was an issue and sometimes it wasn't. So it wasn't everybody having this issue, but it was enough people for me to trigger an alarm in my head that there's probably a problem, I need to fix it. So what did I do to fix it? Well, that's when I went back, did all this research, and came to the conclusion that I need to replicate this so that I can actually see that this isn't working, because I just don't trust it. So I got a project. This was eventually what I came down to try and sort it all out. So here it is. This is not exactly the API that I use, but it's very, very similar to what I was creating. So I just want to show you this, and just so you get a lay of the land. This was the item that eventually was like wanting to be hashed. And I had it as a class because I thought I was going to be fancy and I was going to use this like, well, if no pointers are pointing to it, then the dinit or the deallocation of this object, I could run some custom code to say remove myself from something. I don't know. But either way, that's just what I came up with. Now here, I was using UUIDs. And so UID is actually from Foundation. And UID is just a unique identifier. I forgot how many characters it is, but let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it. That's easy. So I was making one of those with every new custom object, and I was using that as my identifier. So think of I here as like the custom property, but then think of this as like the unique identifier. So I had this in there, and I didn't care about the other properties other than just the UUID. Like when this thing was being created, that's all I cared about, was that that thing is going to be different than all the others. That was my model that I was going for. It works. It's kind of like a hackish on the hashing algorithm, but let's not go there. Let's just say this is where I was going. So I didn't have prints, but I added prints into mine here, just to see like when it was being called. I just wanted to know when my hash was being computed and when my equality was being checked. So with that, I also had this here. So I had this. This was the wrapper. And this is where I was trying to use just the automatic reference counting to then say like, all right, if we call dinit on the custom, and because this is not strongly pointing to it, then I'm just going to take it out and it's going to be nil. And then I always just check for nil anytime I'm getting the content here. So that's kind of the idea of what I was going for. So with that, that's kind of what I had set up. And I had this as a struct, and I had this as a class. And I made this hashable, and I made this hashable. I started with the custom class, and then I made the wrapper, which is a struct, and I did a hashable. And so like I expected this to be kind of like the what the compiler generated for me. However, something that I thought was a little skeptical was, well, first of all, yeah, the weak var here. Maybe that's not what I want to do. But maybe it works, right? The compiler says it works, so it must just be working. And I tested it in the UI, and it worked just fine. So I got to this point where custom, I knew it was working just fine. I could put a bunch in a set, and it worked. Each one had its own individual value. So I made an example here of just loading up a view controller. I'm using view did load and then view did appear because I wanted to see like if nothing's pointing to it, then would it disappear, that kind of thing. Because as I'm creating these all exist on the stack, and it's not until after this function returns that there's nothing else referencing these things strongly, so they'll be deallocated. So that's what I'm going for here. And so I ran this. I'll give it a second here to boot up and run. There's no UI associated with this. It's all just the code itself and printing out to the console. Realize I should make it a little bit bigger so you guys can see. All right, so set count 1, right? Seemed to be working just fine. Now, here's the thing. So I told you a second ago that I was really just using this. So what I should do is take anything related to the I out and just use the UUID. Let's run that. All right, so here's what I wanted to point out. It does say just a set count of 1, right? But there shouldn't be, because every new custom that's being made has a new UUID. So what the heck's going on here? That's not working. So if we look back here, this is a weak reference. And I have a feeling that it wasn't calling my hasher and it wasn't calling my equatable to check to see if it was added in the set or not, right? So that's why I put these print statements here. They're not getting called. That means like it's never checking to see if this is equatable. It's literally just like this wrapper. But why just 1? I'm iterating through this 1,000 times each time. So I'm guessing there should have been 2,000 in there. Yeah, that's what I was thinking. Let me turn this back to what I had before. All right, so now that I can see that like the set's not even like keeping everything that I need. Although like if there was a strong pointer to this, it would, I don't know, maybe it's not even getting the values. So either way, seemed to be working. And then here was my thought. Let me take away this. So that should work, right? Now, when I run this, I should have like, 2,000 things in there because I run it through a loop 1,000 and then 2,000 times. So it should work, right? Let's try it. Give it a run. Yeah, here it is. So look, if I scroll all the way up, let's go back to the beginning. So it calls hash, 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 and then equals, hash, 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 and then equals, hash, equals, hash, 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 equals. So see, it's actually calling it multiple times. Yeah, I don't know. It looks like I inserted it once, inserted it multiple times. I don't know, maybe I should put some breaks in here to see like, because then I put the set count after all of them were said and done. But let's like put it to like just 10, right? So here we go. Putting it in, running it. Here we go, just 10. Yeah, so here's a set count of 20. Yeah. So yeah, this is like basically what I came up with in the end. The other thing I wanted to add here too is, let's say I added in I hashed in with this. So we knew this is different, but then I is also different every single time. So it should work out just fine because UUID should also be different. Let's just run that real quick. Now I know it's calling those hashing algorithm. So let's just see like how it reacts. So yeah, that works too. But now, what if we put in like the same value every time, like this? What would this do? Let's just protect the same value in. All right, so we still got 0 as the custom. And now let's just say this. So now we only put in the I, or wait, I'm sorry, put in both. Let's try and be diligent, put in I for both. Here we go. So I'm trying a different combination, just trying to see if I can replicate the issue or replicate the problem that I had. And so far, I'm not able to do it yet. So here we go. Let's do this. What did I put in as the value there? It said 0. Yeah, here we go. All right, so now I finally actually have like the real issue that I had from before about duplicate elements. And essentially what it's saying, take a look at it here, it's that same issue that I found on GitHub and found in my crash log. So I'm able to reproduce it. I can see how that happens. It's when something is changing, or in this case, always consistently the same for the equatable, but then like this is changing. So it's found like 2 items that are equal, but their hash values are different because this is actually different for every single instance. As you can see here, because I'm putting in 0 every time, it should come out to be equal to, everything should be equal to 0. But then this hash algorithm was just giving a different hash for 2 different objects. And notice it got through quite a bit, and then all of a sudden it didn't work. So I think that's what I'm running into. It was literally just the volume of things that, the volume of times of usage of this that I was running into the issue of, but also the fact that like this here, let's go back to weak custom now, okay? And let's rerun this. I don't think you should be doing this with something that's hashable and relying on the compiler to put it in for you. Because see, it's just 1 again. Clearly it's not 1. These are going to be different objects. Whether I put in the integer value or not, they should all be technically different. But then none of my equality and hash were being called. So that was my way of figuring that out. So I just want you to learn from what I did and don't do that. It should be exactly what you see on the documentation on the website. And use this built-in hasher because it's a SIP hash. Now here's the thing too, like some people say like hash algorithms, they are expensive to calculate, which yeah, they could be. Depends on how many properties are there, how often it's being used. As you can see with resizing, it's pretty big. But like, what if we went into, let's say, let me put in this I again. let's change this not weak anymore and not optional, so that way it calls the actual hasher of this here. So the set, a set of wrapper and minimum capacity. Let's just put in what, 200? Yeah, so go ahead, run that. That way it probably won't have to resize and copy as much, so we save a little time there. See, there's not as many, there's just a lot of hash. Not a lot of equality added in there because it's checking for invariance as you're resizing the. So that could have like fixed my problem maybe to start. That was like one of the issues, but then I had some of this stuff wrong, the equality and the hasher. Now, if you do look at this here, I could make this a struct and then not write this anymore. That's an option too. This is not exactly the types I was using. I was using UUID, but I just wasn't using the I part. So it's more or less like this here. It's kind of a hack because, yeah, I could technically be different, which you'll see here. But I could also be the same. I don't know. That's just what I went with. And so like I didn't set the initial capacity, so it's always constantly resizing. And this is essentially what I ran into as not necessarily an issue, but just something I had to work out and figure out. It was definitely an issue to start with, but now it's not an issue anymore. I have some choices. I have a way out. I can see what's happening with the hasher, how it wasn't being called and how it is now being called. Yeah, so this is something I want you to learn from, and I learned a lot by doing this. If you want to check out more, I have other videos. If you want to take a look, here's a link right now. It's going to be somewhere on the screen to just like sets and arrays and how to use these things. If you want to check out more of what Bruno has to say, Bruno's got a lot of tweets. This is Bruno. He's got a lot of tweets. If you want to check it out, see what he has to say. He's also got a podcast, which I don't understand what they're saying in the podcast because I don't speak the same language. But I'm sure it's good for some of people. And then his website is swiftrocks.com. Has a lot of content on there. So I'm going to look through some of it myself and read more. Native set, if you want to know the underlying how a set actually works, that's going to be on github.com/apple/Swift. Standard library. It's in the standard library for Swift. Yeah, so if you guys have any questions, leave them in the comments below. Otherwise, have a good one. Hope you learned something just like I did.